So in this video, I'm going to show you how to solve a system of equations using substitution. And before we get started, I'd like you to take a moment to look at the two equations that is involved here. If we take a look at this, we notice this is a linear equation. We also notice it's not in y-equal form. So before I do anything with solving with substitution, I'm going to have to put this guy in y-equal form. And if we take a look at this equation, we notice it's quadratic. And so there's several things that can happen here. We could have a system of equations that intersects with one solution, in which case our line would be tangent to our parabola. We could have a system where our line would intersect in two spaces like that. Or we could have a system where there was no intersection at all, and we had a parabola and a line, and no point where they both touch. So let's go ahead and solve this system of equations using substitution, and let's see exactly what kind of a system it is. Like I said before, we've got to get our linear equation in y-equal form, and so that's the first thing I'm going to do. So you'll notice in this first step, I subtracted x from both sides. So minus x here and minus x here. And then I multiplied both sides of this equation by -1 because I wanted to have y equals on the left-hand side, and multiplying -y by -1 will give me my y equal here on the left. So that has the effect of changing the signs right here. -1 times -2 is +2. -1 times -x is +x. And I've rewritten it right here. We most normally use the y equals mx plus b form, so we would most normally write that x term first and the constant term next. Now we have y isolated, and so we can go ahead and set the two equations equal to each other. You'll notice in this next step, what I have on the right-hand side is my linear equation that I just got in the y-equal form. And what I have on the right-hand side of the equation is my quadratic equation from the original problem. So now that I have done my substitution step, I need to solve. And what I'm going to do to solve is I'm going to get everything on the left and get a 0 on the right. And I do that by subtracting x from both sides. So that gives me 24x here. And then I also subtract 2 from both sides. That gives me 72 on the left-hand side. So now that I'm set equal to 0, the next step would be to factor. So I'm going to try and find the roots of this quadratic equation. I happen to notice that I have a GCF. Always when we factor, our first step is to look for a GCF. So notice that all of these coefficients and constant terms are divisible by 2. So the first step is I factor out that GCF. And then the next step, I'm looking for factors of 36 that add up to give me 12. And what I notice is 6 times 6 is equal to 36, and 6 plus 6 is equal to 12. So that's how I want to break up the factors in my quadratic equation. Now, something really interesting has happened here. Both of these factors are the same, so I really only have one root at -6. And that tells me that my equation, my system of equations, is going to have an intersecting point in one spot. And that spot is going to have an x value of -6. Now that I've found the x value, I need to find the y value. So I go up to the original linear equation, and it doesn't matter. You could use the quadratic equation as well, but I use the linear one just because the arithmetic is a little easier. And I substitute -6 for my x value right there, because I know that they intersect where x is equal to -6. I'm interested in knowing what the y value is. So I solved this for y. First I add 6 to both sides. That gives me negative y equals 4. And then again I'm going to need to multiply both sides times negative 1 to get that y to be a positive y. And so what I end up getting is y is equal to negative 4. And that means that on my graph, the intersecting point is at x is equal to negative 6 and y is equal to negative 4. So I would write the answer as an ordered pair. So I'd like to take a look at this graphically, just so you can get an idea of what we're saying. And I went ahead and used a graphing utility to graph both the parabola and the line. And what I notice is if I go over to an x value of negative 6 and a y value of negative 4, that point is both on my line and on my parabola. So now you have the information that you need to know to do in your review packet, problems 17 and 18, and I believe those are on page 3, and also 29 through 32 on page 4. Give those a try.